Welcome to this presentation in which I would like to talk about the wastefulness of our agricultural system, and I would like to enlighten you with some quantitative information. My name is Andreas Pfennig. I'm working at the University of Liège in Belgium, and I have been working on sustainability since 15 years, being a chemical engineer, and I'm active with the Scientists for Future. Now, before the video, you have answered some questions. And of course, I don't know the answer where I record this video, but I guess a little bit what you have stated. You said presumably somewhere between 25% and 1/3 of losses that we have in the food system, that the majority of that is lost in the household level, so by the consumers. And you also possibly said that in your own household, at your home, you're wasting significantly less. If you think about it, possibly some few percent or so. That's what I would expect. Why? Well, simply because that's what the media tell us. And to give you an idea, the World Wildlife Fund on their website, they announce 1/3 of all the food we produce goes uneaten. 45% of all fruit, vegetable, roots and tubers are wasted. Period. That's what they state. And of course, they refer to studies, for example, one here from the UN, the Food and Agricultural Organization from 2011. And they also say roughly 1/3 of food produced for human consumption is lost or wasted globally. Okay. Now, well, I'm an engineer. I look at the data and I try to figure out what they mean by that. And in doing so, I was surprised to find this table in the appendix of this study. And I was really struck by that value and thought, that's irritating me. They state that for cereals, that means all cereal products included, of course, in Europe, on the consumption level, that is on the household level, there's 25% wasted. 25%? Are you wasting 25% of your breakfast cereals, bread, cake, pasta? Me not. And I don't know anybody in Europe who does that, actually. 1/4 of everything on that in this sector of cereals? That sounded too strange. And actually, then I looked, where do these numbers come from? It's not clearly stated. It's actually an estimate. So it's an estimate by the corresponding research groups who prepared that study. And then I looked into those tables a little bit more closely. In another study, for example, about the United States, they also estimated for different products, for fruit, for example, the fresh and processed. I don't know if you can see the numbers, but I'm telling everything that's relevant. They say for the retail of food, they have 1 or 2% that get lost. For food service, that means restaurants and canteens, or consumer food loss, so on the consumption level, in the household level, it's a 50%, 30, 15. These numbers above, they are just accumulated from below. So this is the overall food, this is the fresh, these are the fresh processed, and this is the overall vegetables. And here's some other things, dairy products, 30%. Just numbers, 30 and 15. And of course, it's estimated only because they look, for example, into the garbage bins and say how much is in there. That looks like food. And that way they get an estimate. That's how it is done, how it was done, at least in these studies. Today, they do it in a bit more detail. They take the values that are in the waste collection system, so to speak. There, the people know a little bit of different fractions they get, and from that they estimate that, so it's getting a bit more accurate. But nevertheless, of course, with this study, it's not surprising that in the end they find 27% loss overall in the food system. It has to be somewhere between 15 and 30 if the limits are, so to speak, their estimates of 15 and 30. The accuracy is, of course, quite dramatically bad. Yeah, it's plus minus, I don't know, at least 7.5, so half of this step of 15. Possibly it's even twice that, 15%, I don't know. Somewhere of this order of magnitude I would estimate the error of that. At the same time, you realize the numbers are relatively large. And of course, there's a tendency, there's a trend to publish big numbers. Why? The bigger the number, the bigger the news. The bigger the number, the bigger the news, the more money you get for the next project in that area of food waste. As the more important the topic is, the more money you get for your next study on food waste. And so there is a tendency to publish big data. And there are certain tricks or certain things that are done in a certain way in order to maximize the numerical values that show up in the reports. It's mentioned here in the previous studies, in the early studies, people didn't distinguish between avoidable and unavoidable losses. The unavoidable is the loss, and the avoidable is then sometimes called the waste, because you could avoid it. So you have bones, you have apple cores, coffee grounds, tea bags, eggshells, peels. Would you regard that as waste? I don't know. If I asked you in the estimate that you gave to the question, as an answer to the question before the video, what did you account for that? Presumably not. Yeah, coffee grounds is quite a bit, I guess, over the day. Or tea bags as well, possibly. Then sometimes they include losses that are lost for human consumption but are used otherwise, for example, as feed or for bioenergy, which would need to be produced anyway. So there's a side stream from food processing, for example, that is used as feed. If you wouldn't use that side stream, you would need to grow the feed independently from scratch, so to speak, somewhere in the fields, and we would need to supply that. So the waste stream, so to speak, from food production, from food processing presumably, substitutes something that you would need otherwise to produce. So actually it's not lost in the entire food system. Then that's true, I mentioned already, it uses only rough estimates of the fractions wasted. So it's always going via these fractions, and the estimates are quite coarse sometimes. Then a trick is actually to use the percentage of the final product, not of the produced amount. So if you produce, for example, 100 kilograms, and I tell you 1/3 is lost, what do you think? 33 kilograms, right? No, it's 25 kilograms. Because the way they relate that, they say, well, you have 75% after you have lost from the 100 kilograms, you have lost 25 kilograms, so 75 kilograms remain. And the 25 kilograms that you lost relative to the 75 kilograms that remain is 1/3. That maximizes the number. That's just a bad trick, so to speak. Then something that's wrong throughout all the studies today is the water content. If you have cereals, if you have lentils or peas, you harvest them in a dry state, in many cases at least, and then of course for consumption you add the water, 50% for example. And that means, of course, if you waste now something that contains 50% of water, but that is not accounted for, that's not deduced. So the waste is exaggerated that way as well. And finally, one has to be aware that the losses are typically expressed as mass, as kilograms, and not as calories. And of course, if you look at things that can spoil, milk or whatever, they contain lots of water typically, also fresh vegetables also. It's a lot of water. And those things spoil, you throw them away because they got spoiled. But caloric-wise, that is for the actually the nutritional value is significantly less, because the caloric density of these things is diluted by the water. Yeah, so if you have to throw away a liter of milk, that's much less calories as compared to 1 liter of plant oil. But plant oil doesn't spoil so easily. Also can, but doesn't do so regularly on a household level. Yeah, so actually there, the losses accounted for the kilograms, but not for the actual nutritional value. That's loss will presumably be significantly less. Now, after having said all that, the question is, of course, well, what are now the real numbers? And the real numbers I show here, this is for Germany, because there are a variety of studies available for Germany. The older studies, they don't distinguish between avoidable and unavoidable loss. These two studies distinguish between that, and the gray area is here for the unavoidable losses, and then one study looks only on the household level. There actually the people had to take down really the grams of the things that they throw away. And one should say, well, then if you do need to do that, then you save you save the waste. Yeah, you don't waste so much. But actually these people were involved in a very large food study, and so they knew already about writing things down. So they didn't change their behavior, presumably just because they needed to write down what was lost. So they were accustomed to that already. And what we see is actually that overall the studies agree more or less around 8% is lost throughout the entire process chain for the food. Avoidable and unavoidable loss. We see that on the other hand side, roughly half of what is lost is unavoidable loss. You see significant differences, so there is a big scatter in the data because many of these fractions that are wasted or lost are just estimates. And then you see here the different stages along the food chain, so production, processing, wholesale, food services, canteens or restaurants, and household. And there you see indeed in all the studies the household fraction is largest. Here in these younger studies, then it's roughly, I would say 50%, around 50% of the avoidable loss is on the household level, half of that. You see the big scatter here of the absolute values that is avoidable, but you see the absolute amounts, so to speak, are quite similar. And they agree also with that. So this bar, this is consistent, is very positive. Actually, it shows these values may be quite correct. So what we see is in Germany around 8% overall loss. Half of that, a little bit more than 4%, or around 4% possibly, are the waste, so the avoidable food loss. And half of that roughly is what we lose on the household level. And that's more or less consistent among these studies, especially these three, which are a little bit more detailed. Now, how does that compare? And that also shows a little bit that one has to put that into perspective. Because there is, of course, import and export, and you really don't know what to relate the individual losses to. If you export a lot, then what to attribute the losses to. And this becomes obvious here. This is from two studies that do not distinguish between avoidable and unavoidable loss. So it's all of that, loss and waste. And we see it for Germany. There's the values for Netherlands and EU from one study, and Germany and EU on the other study. We see these two, this were also shown in the previous slide. These two agree more or less quite nicely. With the overall amount, the distribution is a little bit different. On the EU level, these two can be compared. They are also sort of comparable. You see again that there is a significant scatter. And then you see the Netherlands. Why do the Netherlands have such high losses, especially in the processing section? How come? Well, if you think about it, of course, I mentioned that already previously, import-export. In Netherlands, as well as in Belgium, where also the food losses are extremely high, we have the biggest harbors of Europe. Yeah? Antwerp and Rotterdam. These are the biggest harbors that we have. So they're the largest streams, incoming import streams are, so to speak, arriving in Europe. And of course, there you also have some processing companies. So the losses that they produce are then, of course, attributed to, well, the food system in that country, which is, of course, significantly less as compared to, for example, Germany or so, because there are significantly fewer people. And that, of course, maximizes the error, the waste that you attribute to the individual person in that country. And that is, of course, not fair. On the other hand side, one has to say, if you look at Europe as a whole, import and export of a comparable order of magnitude, so there you would expect that this balance mismatch by import and export, so to speak, is not as dramatic. And there we see that we have something somewhere around 12% of overall food lost and wasted. And we can, of course, then apply that to what we learned before. Roughly half of that is avoidable, and roughly half of that is then household, so 6% roughly on the household, on avoidables along the entire process chain, and around 3% avoidable on the household level. So these are the numbers. It's not 1/3. The avoidable loss is somewhere around, in the EU, around 6% presumably, and in the households only 3%. It's still a rough estimate. You get a little bit of feeling of the uncertainties, but it's not 1/3, definitely not. And to also show a little bit the difficulties that one has with the import and export, I want to show this so-called Sankey diagram for Germany, for the German food system. It's in German, but I mean, it doesn't matter so much to read all the things. This is along the value chain, more or less. I circled everything that is waste. And here you see actually that these streams are relatively small, and this is not just waste, it's waste plus loss. All that is, so to speak, relatively small arrows as compared to what's going on in the overall system. There you also get a visual impression how little that actually is. It's not 1/3 that's getting lost. Okay, so one could now say, well, it's so little it doesn't matter. But on the other hand side, we have to keep in mind there are lots of people that are undernourished, globally speaking. Around 800 million today. You see the strong increase during the corona crisis. And of course, every person who is not sufficiently supplied with food is one person too much that is not supplied. So we have to save every single % of our waste in order to be able to supply sufficient food for everybody. It can contribute to that a little bit. We should avoid waste as much as possible to avoid and to decrease world hunger. And you see on the other hand side, the Sustainable Development Goal is to reach the no hunger goal in 2030. If you look at that diagram, that won't happen if we continue on like this and modify our food system only slightly. That won't work. We have to come up with fundamental changes, otherwise it won't work. To put that in another perspective, this is showing the entire world population. The undernourished I mentioned already, roughly 1/10. Then the severely food secure, that means people at least during some time of the year don't have enough foodstuff. Moderately food insecure means the quality is not sufficient, so there is some malnutrition that is happening for these people. And you see roughly 3 billion, more than 1/3 of the world population is not properly fed, is not properly supplied with good foodstuff. On the other hand side, you have, of course, the top 10%, which is then struck by obesity, where obesity is really, if the BMI is extremely high, so it's really sick from having too much food intake, presumably. There are also illnesses that induce that, but most of the time it will be just eating too much. So there is some mismatch, apparently. This is one thing. People, more than 1/3 of world population, not properly fed. There's another issue, and that guides us to another aspect, actually. The rainforests in Brazil, for example, are burning. They are burning because we use the food, we use the area for food production, especially animal-based food production, that is feed production or as pasture. And that doesn't have anything to do with food losses, right, or food waste, right? It's something completely different. So let's follow that perspective. Here's apparently something about land area. So let's have a look at land area a little bit more closely. Here I plot the available agricultural land per person. It's roughly, on the global average scale, 6,500 square meters for everybody of us. It's roughly one soccer field. That's what we have available. Now, what are we doing with that? We are producing food on that, foodstuff. We are producing biofuels on that. We are also producing biomaterials, bio-based materials on that. That will increase actually in the future. And if we add all that up, it contributes so much to the overall use of the land area. Everything is more or less drawn to scale. So what's the rest? Well, the rest is for feed production and it's pasture. So the largest fraction of the land area is actually used for animal-based food production. That's the situation today. Now let's look into the future, for example, to 2050, and then we know that world population will be strongly increasing by then. And that in turn means, of course, since the overall land area is given, it doesn't change, not significantly at least in this short period of time, it means that per person we have significantly less land area available. Yeah, significantly less. And now the question is, can we still manage to produce sufficient food? Well, luckily, the agricultural productivity has been continually increasing throughout the last at least 50 years. And that means if you evaluate that quantitatively, it more or less just works out. This little bit here is the uncertainty of this very rough projection into the future, more or less. Fine. But, there's a very big but. This is my way to work. Actually, it was 2 months ago at the time where I record this video. I can't use it anymore. The bridges are gone, or some of the bridges are gone. So I have to take a very big detour to reach my working place, the university. There have been extreme wildfires this year. We know that the sea level is rising. It's continually rising, and the speed of this rise is increasing. At the same time, we know that much fertile land is close to the shores in different countries, especially in the river deltas. The Mekong Delta is one of the very fertile land areas in Vietnam. If they don't have that anymore, they have a problem. And the height above sea level is just 2 or 3 meters. So if the sea level will rise significantly, they have a severe problem. And 2 meters is the rise roughly predicted in the worst case scenarios until the end of this century. So it's not far away. This sea level rise means actually at the current temperature, our Earth system is unstable. So what we actually need to do, we need to go back to a temperature which is less than today's. That means all the CO2 we will be emitting in the future, we have to remove again. And even we need to remove more until we get to a temperature lower than today. How can we remove that? We can do that with technical means that are extremely expensive, they are extremely energy consuming, so they would delay the renewable energy transition significantly, and they would cost extreme amounts of money, much more than we actually have. And that in turn means actually that can't be realized. We have to resort to other means. And there are cheap means available. Afforestation, so the reverse that we are doing as we are doing today with burning the rainforests. We can use bioenergy with carbon capture and storage. So we grow biomass, we burn it, use that energetically, and the CO2 from the flue gas we are then recovering and pumping underground. That's actually done. It can be done. It has been shown that it works. It's actually one technique to in oil drilling that you recover more of the oil by pumping in some CO2. So it stays there, no problem. And there is a large storage capacity, large areas where you can really store that underground, so it should be manageable. There is a dispute about that. I don't want to hide that, so to speak, but it can be done. That's the only chance that we have at the moment, really. So we can do that to remove CO2 from the atmosphere, but we want actually more. We want to have sustainable farming, yeah, all organic food, right? And that means, of course, unfortunately, that we need roughly 15% more land area because the productivity of organic farming is roughly 15% less as compared to conventional farming. We also know that biodiversity is endangered. So we need to save biodiversity by having some flower strips or some fallow land. And that, of course, means we need more land area. All that requires more land area. And if we add that up, what I mentioned, yeah, more bioenergy for the backsport, more biomaterials to substitute our fossil resources at the moment, afforestation, organic farming, these flower strips and fallow land here, there's no space left for animal-based food production. It matches exactly. So if we avoid animal-based food production, we will still be able to run a sustainable agricultural system with all that, taking all that into account that I mentioned previously to a sufficient degree so that we get stable as soon as possible. I should say really becoming stable as soon as possible still means a century of pulling down the CO2 from the atmosphere. It's a long-term perspective, of course, or medium-term, what should I actually say. But we see no animal-based food is possible. None. Why is that so actually? Well, because the agricultural production of animal-based food is highly inefficient. 20% we are using for plant-based food at the moment of the land area that we use for foodstuff production, 80% for animal-based food. And if you look at the output, it's only 18% that is for the animal-based food. Roughly half is meat, and the rest is dairy products and eggs. And actually what you're doing, you are wasting 95% of the land area. If you would want to produce the same amount of calories, you would need only 5% of the land area that you're currently using for the animal-based food production. So 95% of the land area are wasted. And on the caloric level, you also waste a lot. We need 2 kilocalories of feed from the global statistics, plus all the kilocalories that the animals take up from the pasture to produce just 1 kilocalorie of animal-based food. And that means not even accounting for that, it only says it has to be at least 50%, it will presumably be significantly larger the value, at least 50% of the calories that we have as input to the animal-based system are lost. or actually wasted. And with that, we can start to summarize a little bit and take the overall perspective. What we see actually, the losses here are much more, significantly much more than these few percents that we have seen for the actual food losses that we have in the food that we are wasting on the household level. Yeah, these are gigantic values, 95% loss, it's unimaginable, whereas for the food losses it's just, well, somewhere of the order of some few, possibly 10%, but not significantly more. That puts things a bit more in a different perspective, possibly. So we see that the rainforests are burning and people are starving, and that means that, of course, any food waste anywhere should be avoided, if it is avoidable, of course, but that will only contribute few percent to the overall perspective that we have, what the agriculture has to deliver, so to speak, today as well as in the future. 95% we have waste for the land area with respect to animal-based food production, more than 50%, at least 50%, presumably significantly more with the kilocalories for the animal-based food. And we see, again, rainforests are burning, people are starving, but also in the future we need more land area to reach sustainability. And this we can only afford if we do not waste all these things, so we cannot afford wasting any kilocalories or land area, these two especially for the animal-based food, and that means we need to switch to plant-based food. We need to be vegan, otherwise it does not work out, or it will be getting significantly more expensive, so that actually the poor countries will even get poorer, or more people will be starving, or more rainforests will be burning. We have the choice. Yeah, and that all links via the land area to a large degree. Just saving food waste contributes little to get us sustainable. Yeah, that these few percent are not sufficient to do all that is required to get sustainable. And finally, I would like to stress that applies today. It's not some future perspective. So even if we looked for 2050, it applies today. Because today the rainforests are burning, today the people are starving. And with that, I would like to end this presentation. I hope that I have given you some quantitative insight into the different aspects of the wasteful agricultural system. It's by far not just the food waste that is generated, and one should only look at the avoidable food waste, which is only some few percent, overall significantly less than 10%, and in the household level only very few percent. And the major waste is actually for the animal-based food production, and that should, as I have hopefully made clear, be avoided more or less instantaneously. Only then we can afford to become sustainable, or only then we can become sustainable. So with that, I'm at the end of this presentation. Thanks for watching, and I hope that you will have good discussions after this video.